Hello class, in this lesson we're going to learn how to calculate the distance from a point to a line. So here's a robot example, and we know the equation of the path of the robot. And there's a homing beacon at the point 3540. We want to know where will the robot hear the loudest ping. Now, as we previously saw, that will occur when the robot is closest to the homing beacon. And it will be closest when this is satisfied. To do that, we got to figure out the equation of the line that goes through the homing beacon and is perpendicular to the path. Because when the line is perpendicular to that path and it goes through the homing beacon, that's always going to give us a way to calculate what that shortest distance is. So in order to do that, we got to figure out what the slope of this line is. So I'm going to write it in slope-intercept form. Okay, subtract 20x from both sides, divide by 30. So the slope of the path is negative 2/3. So for a perpendicular line, take the negative reciprocal, it will be 3/2. So we could write the equation in slope-intercept form. We could write it in point-slope form. It's up to you. You got the same answer in the end. If we write it in point-slope form for the perpendicular line that goes through the homing beacon, it would be this. And if we add 40 to both sides, we isolate y. And we want to do that because we want to figure out where do these two lines cross. Right, we want to find the point of intersection. So I'm going to use substitution. That's why I solved for y in both of these. So now since they're both equal to y, we can set them equal to each other. And we can solve this. There's lots of ways to solve it. I like to clear my denominators. So the least common multiple, least common denominator here is 6. So we multiply every term by 6. And we end up with this equation. So now when we distribute here and we simplify, we end up with this equation. All right, let's move all the x's to one side, move all the constants to the other side, and divide by 13, and we get 15. So to figure out what y is, we substitute. All right, I plugged into this equation from the point-slope form, and we end up with 10. So it will hear the loudest ping at the point 1510. So now that we know the equation of this line and the point of intersection, we can calculate how far the beacon is from the robot at this point. Right, you can use Pythagorean theorem or the distance formula. If you use Pythagorean theorem, you will end up with leg lengths of 20 and 30. And when we square those and add them together, we get 1,300. Take the square root of that, and we get about 36.1 units. So that's how we can calculate the distance from a point to a line. Let's do a similar example. So we have our point P, it's the origin, and we have this line, y equals x plus 10. So why don't you try to solve this one on your own, and then I'll show you my solution. So we know the slope of the original line is 1. Right, coefficient there is 1. So if we take the negative reciprocal of that, we get -1. All right, so we want a line with a slope of -1 that goes through the y-intercept, which is going to be 0 because P is 0, 0, the origin. So that's pretty straightforward. We just get the equation y equals -x. So we want to know where will this cross the point y equals x plus 10. So we solve the system. All right, both equal to y, so we get this equation. Get the variables on one side, get the constants on the other, divide by 2, and we get x is -5. So if x is -5, plugging that in up here gets us y is +5. So it looks like this. And so if we use Pythagorean theorem or distance formula, we will end up with, let's see, what do we get? The square root of 50, right? Because they're both 25. Now it wants an exact answer, so we should also put it in simplest form. So yes, square root of 50 is exact, but it's not in simplest form. 25 is a factor of 50. And so we get the answer 5 radical 2. In this lesson, we learned how to calculate the distance from a point to a line. Thank you for watching this video.